Today we have Khan University Examination Board Class 9 Physics of May Examination 2014 Paper 1. In this video we will solve the different MCQs in this exam with their explanation. So let's come to the first question that we have in this paper. And in this paper, we have the question number 1, that is from chapter number 1, Physical Quantities and Measurement. Which of the following is the correct number of significant figures and the standard form in this expression, that is 0.0340 centimeters? So we have to identify two things. One is the number of significant figures and other is its scientific notation. So the 0 and the 0 are the starting zeros of a decimal number. This means that these zeros are non-significant, while 3 and 4 are always significant. And this 0 is the ending zero of a decimal number that makes this 0 significant. So overall, we have 3 significant figures. For making this expression into scientific notation, this decimal should lie between this 3 and 4. This makes this expression as 3.4 and exponent minus 2. This exponent minus 2 shows that we have displaced our decimal towards the right and two digits towards the right. That makes the exponent minus 2. So we have the correct option, that is option number B. Let's come to the next question, that is question number 2. And in this question, we have, this is from chapter number 1, Physical Quantities and Measurements. The mass of the empty sugar container in this given diagram. So in this diagram, we have empty sugar bag, we have 1 kilogram of sugar bag, means we have 1,000 grams in it. And this sugar bag is placed on digital balance that measures this value as 1008.9 gram. But in this bag, we have only 1,000 grams of sugar. This means that the excess amount of mass is of this empty sugar bag. This means that the mass of this empty sugar bag is 8.9, because the 1,000 gram of sugar is placed inside it. So the remaining mass will be obviously for of this empty sugar bag. So this were the two questions from this chapter. Let's see what we have in another question, that is question number 3. In question number 3, all of the following are the role of physics with an exception. There are 3 rules of physics in these options, and we have one exception, that is not the role of physics in our daily life. So question number 3 is from our chapter number 1, Physical Quantities and Measurement. So one of the use in our daily life of physics is the use of measuring instrument. This is very obvious, the role of physics in our daily life. Similarly, the use of electronic as well as the use of internet, that is the main basic role of physics. So the first option, that is the use of vaccines, this is not the role of physics in technology, rather this is the role of biotechnology. So the correct option we have is option A. Question number 4, that is from our chapter number 2, Kinematics. When an object of mass 2 kilogram is dropped from a height of 125 meters, then it will reach the ground in how many seconds? So as we can see in this question, that an object is dropped, it's mean its initial velocity will be 0 and the height that it has is 125 meter, while the gravitational acceleration is plus 10 meters per second square. So let's apply the equation of motion, that is second equation of free fall motion, VIT plus GT square over 2. By substituting the values, height we have is 125, initial velocity is 0 multiplied by time plus value of G10, T square over 2. This will become 0 and this 2 and 10 will cancel out. So we will have 125 is equals to 5t square. So t square will be equals to 25. So finally our t will be equals to 5 seconds. So we have the correct option, that is option A, 5 seconds. So let's move to the other question, that is question number 5 and 6. In question number 5, your car travels at an average speed of 80 meter per second and covers a distance of 640,000 meters. So we have to calculate the time. So by applying the simple formula of speed, that is distance over time. So this is our question from our chapter number 2, Kinematics. For the time, this expression will become distance over velocity. The distance covered by the body is 640,000 and the time is, sorry, velocity is 80 meters per second. So the 0 and 0 will cancel out and the 8 1 is 8 and 8 8s are 64. So we have got the answer, that is 8,000 seconds. The correct option is option B. Next, we have question number 6, that is from our chapter number 3, Dynamics. Ball bearings are mostly used in variety of light and heavy machineries, simultaneously with some vehicles in their moving parts or in their wheels. So the reason for using these ball bearing is that this reduces the friction between the tires and the different parts of the machines. So how does this ball bearing reduces the friction? That these ball bearings have the less contact area with the surface, that reduces the friction and the energy loss between the parts of the machineries. So these ball bearings, or use of this ball bearing, the main purpose is to reduce the contact area, that eventually reduces the friction and the energy loss in that machinery. And we have correct option, that is option D. So let's come to the other question, that is question number 7. And in question 7, let's see what we have in this. An object is moving with a uniform speed in a circle. If the radius of the path is doubled, then what will happen to the centripetal force? So this is our question from our chapter number 3, Dynamics. And what this question is asked, that what happens to the centripetal force, that is equals to mv square over r. If we increase the distance, or if we double the distance or the radius of the circular path, so what will happen to the centripetal force? So as we know that this force, centripetal force, is inversely proportional to the distance of the, or the radius of the circular path. This means that increasing the radius will reduces the force. So doubling the distance or doubling the radius of the circular path, it's mean our force will reduce to half. Force will reduce to half. So we have the correct answer, that is option A for question number 7. Next, we have question number 8, that is also from our chapter number 3, Dynamics. In this question, we have two spheres A and B, and they are dropped from the same height. If the sphere B has mass 3 times greater than the sphere A, so these two spheres, in which one sphere is lighter while the other sphere is heavy. Let's say we have these spheres. This is sphere A and this is sphere B. So according to the Newton's equation or Newton's theory, these two balls will fall towards the ground in the same time. They will reach the ground in the same time, but due to the difference in mass, the velocities of both the bodies will be same. But question is asking about the momentum of the bodies, that which bodies had the greater or the less momentum. So for velocity, we can see that both bodies can have the same velocities while falling towards the ground. When both bodies are falling towards the ground, they will gain the velocity, or the gain in velocities will be same for both the bodies. But due to difference in their masses, this mass, it has mass m, and this has mass 3m. So obviously, the greater the mass, greater will be the momentum. So the sphere B will have the more momentum as compared to body A or sphere A. So we have the correct answer, that is option C. And we know that momentum is equals to mass multiplied by velocity. The body with greater velocity will have greater momentum, and body with the greater mass will have the greater momentum. So both bodies will have the same velocities at each instant. So greater mass will have the greater momentum. Let's move to the other question, that is question number 9 and 10. So this question number 9 and 10 we have from our chapter number 4, turning effect of forces. And in question number 1, if a person is tightening a bolt with a force of 10 Newton at a point zero point 0.8 meters from the point O, or the axis of rotation, we have to find the turning effect. So this is the force and this is the moment arm. The question is very simple. Torque is equals to force multiplied by moment arm L. The value of force is 10 and the moment arm is 0.8. So after multiplication, we will get 8 newtons meter. So correct answer for this question is option A. Next, we have question number 10, and in this question, we have a car in which the center of gravity, or the point of center of gravity, is marked as at the center of this car. And when a car is tilted from the ground, when this car or this car is tilted, what will happen to the position of center of gravity? So as we can see, if the car was originally in the normal condition, this point center of gravity would be lowered as it is given in the diagram. So when we disturb or when we tilt the car, this center of gravity has raised, and the raising of this point of center of gravity shows that this car is in stable equilibrium, and after releasing the force, this car will come to its original position. So the correct option in question number 10 we have is option D. So next we have question number 11, that is from chapter number 4, turning effect of forces. In these options, we have the application of turning effect, or the use of turning effect with an exception. In one option, there is no turning effect, while 3 of the options will have the turning effect, in which tightening of a tab is due to the turning effect. Releasing a nut with a spanner, in which force will produces the turning effect, while picking up an ice cube with an ice tongue will also produces the turning effect. So this dabbing paint with a paintbrush, that do not include the turning effect of force. Next, we have the question number 12, that is from our chapter number 5, Gravitation. And this is the same question we have also solved in the previous exam papers. So the given diagram shows the path followed by a comet when it reaches close to the sun. Then we have to tell about the shape of this path. So comet are the icy bodies that revolve around the earth, revolve around the sun, and these icy bodies revolve around the sun in nearly elliptical path. The path of these icy bodies is elliptical. So the correct option for this question is option number A. So let's move to the other question, that is question number 13. And in question number 13, it is from our chapter number 5, Gravitation. If the mass of the earth is 6 exponent 24 kilogram, and we have the radius of the earth as 6.4 exponent 6 meter, we have the value of gravitational constant, that is capital G. Its value is given in the question. Then we have to The value of the gravitational force acting on a 1 kilogram of body which is placed on the surface of the earth will be. So we have different two bodies actually. This is earth and this is the body. So mass of this mass of this body is 1 kilogram, and mass of earth is given as 6 exponent 24 kilogram. The distance between these two bodies is equals to radius of the earth, that is 6.4 exponent 6 meters. So we have the formula, that is F is equals to G m1 m2 over r square, and this will become G m me over re square. So by substituting their values, G is equals to 6.67 exponent minus 11 multiplied by 1 multiplied by mass of earth, that is 6 exponent 24, divided by radius of earth square, 6.4 exponent 6 square. So after the simplification of this whole expression, we will get the correct answer, that is equal to 9.8 of newtons. So the correct option in this question is 9.8. So question number 14, that is again from our chapter number 5, Gravitation. The necessary acceleration for a satellite orbiting the Earth. So it is provided by the gravitational force between the satellite and the Earth. As we know that the satellite that revolves around the earth in a circular path, and the force required for moving in a circular path is the centripetal force. So in case of centripetal force, in case of the satellite and the earth, the centripetal force that is required to move in a circular path is provided by the gravitational force that exists between the satellite and the earth. So let's move to the other question, that is question number 15 and 16. So this is our question from our chapter number 7, Physical Properties of Matter. On which of the following factors does the pressure inside the liquid depends? So as we know that the formula for the pressure under the liquid is the rho, G and H, where P is the pressure, rho is the density, G is the gravitational acceleration, while this H is the depth under the liquid. So force and area is the wrong answer. Upthrust and density and depth are the wrong answer. So the correct answer for the pressure inside the liquid, sorry, we have this force and depth is the wrong answer. So we have the correct answer for this question number 15 is the density and depth. So question number 15, the correct answer is option C. So next we have question number 16, that is from our chapter number 6, Work, Power and Energy. So if a spring is stretched by hanging a piece of metal, so a spring is stretched in this diagram, so we have to tell that which type of energy is stored in this spring. So as we know that when a spring is stretched or compressed, the type of energy that is stored in that spring is the elastic potential energy. So the correct option, question number 16, is option C. So let's move to another question, that is again from our chapter number 6, Work, Power and Energy, and the same type of question that was question number 16, in which we have to tell about the elastic potential energy. So in all these diagrams, which spring will have the greatest elastic potential energy? So as we know that the elastic potential energy is due to the stretchness in the spring or elastic body. So among these four diagrams, the more stretched body or the more stretched spring is this, that is 2 centimeter. So the greatest elastic potential energy will be in option C. So the correct option in question number 17 is option C. So let's move to another question, that is question number 18. Next, we have question number 18, that is from our chapter number 6, Work, Power, and Energy. The given graph shows the force acting on a moving object and what will be the amount of work done on the body during the displacement of 12 meters. So this graph shows this graph is between the force and displacement, and the area of this graph is equals to work done on the body. So we have to calculate this the area of this whole graph, in which we have a rectangle and one is triangle. So the length of this rectangle is 10 while the breadth of this rectangle is 6. So length into breadth, the area of the rectangle will be length multiplied by breadth, that is equals to 60 joules. While this triangle, the area of this triangle is equals to base into height divided by 2. The base of this triangle is 2 and the height of this triangle is 6. So 2 and 2 will cancel out with each other. So the work done is 6 joules. So total overall we have 66 joules of work done on that body. So the correct option is option C. So quickly, let's move to another question, that is question number 19. And in question number 19, a ball of mass 2 kilogram is moving up from point B to point A. A potential energy at point A with respect to the ground will be. So the height from the ground is 3 centimeter. This means 3 divided by 100 will be equals to 0.03. So potential energy, we know that it is equal to mgh, where mass of that body is 2 kilogram, gravitational acceleration will be 10, and height is 0.03. So after the multiplication of these three numbers, we will get 0.6 joules. So the correct option for question number 19 is option C, 0.6 joules. Let's move to another question, that is question number 20. And this question is from our chapter number 7, Physical Properties of Matter. In this question, we have three balls of the same diameter. So this means that if these three balls have the same diameter, so the volume of these three balls will be same. Volume same. Then these three balls are immersed in water, and which of the following statement is correct about the upthrust on the ball? So these three balls will have the same diameter and the same amount of volume. So according to Archimedes' principle, when these balls are immersed in liquid, they will displace some amount of water. Displaces water that is equal to their volume. So these three balls have displaced the same volume, but they have displaced the equal amount of volume, and all these balls will be forced by water. All these balls will get a force that is applied by the water on them, so that this force is equal to the weight of the displaced liquid. So the upward force that is acting on them is equal. So this is the force that is applied by the water, that is displaced by these three objects. So the actual weight of these three balls is not same. The aluminum will have the more weight, while the cork will have the less weight. So this shows that the cork ball will have the maximum upthrust, because the weight is the less among these three balls, and the liquid displaced by all three balls is same. So the option B is correct for question number 20. Let's move to question number 21. And this question is from our chapter number 7, Physical Properties of Matter. And people feel cool when they do not dry themselves after swimming. So, we have to tell the reason why this process occurs or why they feel cool. So after swimming, the some amount of water is left on their bodies, and those water molecules absorb energy from the body and surrounding and evaporate from the surface or evaporate from the body. So as we know that evaporation causes cooling effect, this is why the people felt cool after when drop of waters from their bodies is evaporating. So the correct option for this question is option C. Next we have question number 22, that is chapter number 8, thermal properties of matter. The temperature of the chicken pizza is 75 degrees centigrade, and we have to find this temperature in Fahrenheit scale. So we know that the conversion factor between them, F is equals to 1.8 C plus 32. So substituting the value 1.8 multiplied by 75 plus 32. So after solving this expression, the value of this question of the value of 75 degrees centigrade in Fahrenheit will be 167 degree Fahrenheit. So the correct option for this question number 22 is option C. Let's quickly move to the next other question, that is question number 23 and 24. The question number 23 is from our chapter number 8, thermal properties of matter. So we have a bimetallic strip in which the upper metal has the smaller band. If the upper metal is a small and smaller, and the lower has a greater thermal expansion. So if this is the if this is the bimetallic strip in which this is the upper metal and this is lower metal. So when we heat this rod or bimetallic strip, this strip will bend in the upward direction because the lower type of metal surface has a greater thermal expansion. So due to the greater thermal expansion, this lower metal surface or lower metal rod will bend more as compared to the upper metal surface. So the correct option for this question is option A, that this bimetallic strip will bend in the upward direction. So let's come to the next question. We have question number 24 and 25. In question number 24, when a saucepan is placed on a burning stove, heat is transferred to liquid inside the saucepan. So in this question, we are asked about the mode of transfer of heat, that is from our chapter number 9, transfer of heat. So heat is transferred to liquid into the saucepan. So as we know that the transfer of heat or the mode of transfer of heat through liquids is known as convection. So the correct option is option B. Next, we have last question, that is question number 9 from the same chapter, chapter number 9, modes of transfer of heat. Heat is transferred from one body to another body. Whenever the energy that is transferring from a hot body to a cold body, when there is a thermal contact between them. So this transfer of energy is only due to the temperature difference between them. If there is no temperature difference between them, there will be no transfer of heat, or rather the transfer and absorption will be same. So the correct option for this question number 25 is option B.